Assalamu alaikum wa rahmatullahi wa barakatuh. This is the third video in Chapter 8, Electromagnetic Induction. At the end of this video, you should be able to state and apply Lenz's law. First, let's remember the concepts of the previous video. 1. Electromagnetic induction is the induction of an electromotive force E in a conductor when it is placed in a variable magnetic flux. 2. The variation of the magnetic flux is obtained either by the variation of B or by the variation of S, or by the variation of the angle formed between B vector and N vector. 3. The variation of the magnetic flux in a circuit produces an induced electromotive force E and an induced current E when the circuit is closed. Laws of electromagnetic induction. Lenz's law. According to Lenz's law, the direction of the induced current is such that by its electromagnetic effect always opposes the causes creating it by electromagnetic induction. Applications on Lenz's law. Variation of the magnitude of the magnetic field. In this experiment, we are going to use a coil and a magnet. As the magnet approaches the coil, the inducing magnetic field B created by the magnet traversing the coil increases, while as the magnet moves away from the coil, the inducing magnetic field B created by the magnet traversing the coil decreases. So, according to Lenz's law, the induced current produced in the coil create an induced magnetic field BI, which opposes the variation of the magnitude of the inducing magnetic field B. So, as the magnet approaches the coil, the magnitude of B increases. Hence, BI vector and B vector have opposite directions, while as the magnet moves away from the coil, the magnitude of B decreases. Hence, BI and B have the same directions. We can determine the direction of the current in the coil by using the right-hand rule. Variation of the magnitude of area swept. In the case of the variation of S, according to Lenz's law, the electromagnetic force F exerted on the rod always opposes its velocity v, which means that the force F and the velocity v have opposite directions, and the direction of the induced current I in the circuit is determined by the rule of 3 fingers of the right hand, where the fingers represent the directions of I, the intensity of the current, B, the magnetic field, F, the electromagnetic force. Application 3. Given the 3 documents. Document 1, ABCD conductor is placed in a magnetic field B where its magnitude decreases with time. Document 2, the rod MN moves under the action of a force F on the 2 parallel rails placed in a uniform magnetic field. Document 3, the magnet approaches the solenoid along its axis. Question. Specify, applying Lenz's law, the direction of the induced current in each of the induced circuits given in the adjacent figures. Document 1. The magnitude of the magnetic field decreases with time. Hence, the induced current I traverses the circuit in order to create B induced in the same direction of B inward. Therefore, according to the right-hand rule, the current traverses the coil in the counterclockwise direction. Document 2. The induced current opposes by its electromagnetic effect the cause that produces it. The Laplace force then opposes the direction of the displacement of the rod. Then, according to the right-hand rule, the induced current passes through the rod from point N to point M. Document 3. In order to oppose by repulsion the approach of the n-pole of the magnet according to Lenz's law, A is the north face, B is the south face. The induced magnetic field BI is directed from B to A opposite to B. Therefore, according to the right-hand rule, the induced current circulates from A to B through the solenoid. Summary. 1. According to Lenz's law, the induced magnetic field BI opposes the variation of the inducing magnetic field B. 2. When the inducing magnetic field B increases in magnitude, the induced magnetic field BI and B have an opposite direction. 3. When the inducing magnetic field B decreases in magnitude, the induced magnetic field BI and B have the same direction. 4. According to Lenz's law, the electromagnetic force F exerted on the rod in the case of the variation of S always opposes its velocity V. This is the end of the third part. Study it well and thank you for your attention.